Hi, I'm Michael Leung from the Department of Environmental Health at the Harvard T.H. Chan School of Public Health. Today, I'm excited to introduce to you an article I wrote with Mark Weisskopf, which will appear in the September 2023 issue of Epidemiology. Previous work on gene by environment interactions has shown that the impact of misclassification bias on these interactions is always towards the null if two conditions hold. The first is that the misclassification is independent of the genotype. The second is that the environmental exposure is independent of the genotype. Now, the first assumption is often reasonable, but the second assumption may not always hold, and this can happen due to several reasons, such as errors in selecting controls, population stratification, or even because the genetic variant is causally related to the environmental exposure. In our paper, we show that even if gene-environment independence does not hold, the direction of bias, and thus often the true interaction, can still be identifiable. We show this in the context of a recent paper looking at Gulf War illness, a chronic multi-symptom disorder which many veterans experience after the first Persian Gulf War, and the interaction between nerve agent exposure, which is often determined through self-report, and so is likely overreported, and the paraoxonase 1 gene, which is a known genetic determinant of susceptibility to organophosphate cholinesterase inhibiting chemicals, including nerve agents. In our paper, we derive equations to quantify the bias of the gene by environment interaction and numerically illustrate these results by simulating a case control study. We show that we may still be able to identify the gene-environment interaction in two simple steps. First, estimate the strength and direction of the gene-environment dependence and the gene-environment interaction. And the second step is take the inverse of the gene-environment dependence and compare it to the observed interaction. If the observed interaction is smaller than the inverse of the dependence, then the true interaction must be smaller than the observed interaction. But if the observed interaction is larger than the inverse of the dependence, then the true interaction must be larger than the observed interaction. Furthermore, we show that the magnitude of the bias is determined by several other factors, such as the specificity of exposure recall, exposure prevalence, the exposure main effect, and the directions of the recall bias and gene-environment independence. So our goal with this paper is to show that the exploration of interactions does not have to be constrained by the independence assumption. We invite you to work through our math and also check out our simulation study, and we hope that you enjoy the paper.